Hello, my name is Russ Baker. In this segment, we're going to define the arithmetic sequence, show you how to find any given term, and the sum of any given number of terms. Let's get started. First, we'll define an arithmetic sequence to be any a sub n is found by taking the previous term, a sub n minus 1, and adding d, called the common difference. So any term is the previous term plus a common difference. If we want to find an nth term given the first term, we could use a formula like this. The nth term is the first term plus n minus 1 times that common difference. That's an arithmetic sequence. The thing that makes it arithmetic is that we are getting from one term to another by addition. Let's do an exercise. Write the first 5 terms of the arithmetic sequence whose third term is 10 and whose common difference is -2. Let's see, it says the third term is 10, so we know A3 equals 10. The common difference is -2. What we really need to know now is what the first term is. We can use the formula an equals a1 plus n minus 1 d, because we know that our an is really a3, so that's 10, and we don't know what a1 is, but we know that if we're looking for 3 here, that 3 minus 1 is 2 times -2 for d. 10 equals a1 minus 4, so a1 equals 14. Now that we know a1, the first term, we can write all the 5 terms as required. a1 is 14. The difference is -2. So 14 minus 2 is 12. The common difference is -2. 12 minus 2 is 10. 10 minus 2 is 8. And 8 minus 2 is 6. We've written a1, a2, a3, a4, and a5. And we've done our first 5 terms. Now here's one for you to try. What are the first 5 terms of an arithmetic sequence with the first term of 8 and a common difference of 6? Turn off the tape, write the 5 terms, and then return. Did you write down your 5 terms? Let's see what they are. In this problem, we know that the first term is 8. We know that the common difference is 6. So in order to find the next terms, we'll just find a2 must be 8 plus 6, or 14. a3 is the previous term, 14 plus 6 is 20. The fourth term is the previous term plus 6, or 26. And the fifth term is the previous term plus 6, or 32. I hope you got those 5 answers okay. Let's go on. It's also possible to find the first term and the common difference given any 2 original problems. Let's look. If we know that a5 is 27 and a15 is 87, we'd like to find a1, the first term. Let's see what that means. We're going to use the formula an equals a1 plus n minus 1 times d. For a5 equals 27, we know that a5 equals a1 plus 5 minus 1 is 4. We also know over here that a 15, the 15th term, is equal to the first term plus 15 minus 1 is 14d. We can substitute the numbers in and get for a sub 5 and a sub 15, and then our only unknowns will be a1 and d. a5, 27. a1 plus 4d. a15 is 87 equals a1 plus 14d. We'll now solve each of these two equations for a1. 27 minus 4d equals a1, and a1 equals 87 minus 14d. We can now set each of the equations left sides or right sides in terms of d and substitute out the a sub 1, like so. 27 minus 4d equals 87 minus 14d. Let's add 14d to both sides. That will make it 27 plus 10d equals 87. And then subtract 27 from both sides, leaving us with 10d equals 60. And then divide both sides by 10, and now we know that d is 6. Knowing that d is 6, we can go back to either one of the original equations that we started with. If we start with the 87 equals a1 plus 14d, now the d is 6, and we have 87 equals a1 plus 84. Subtract 84 from both sides, and we now know that the first term is 3. When we know that the first term is 3 and that the common difference is 6, we can go ahead now and find any other terms of the system that we were interested in finding. We can also find the sum of any number of terms of an arithmetic sequence. If an arithmetic sequence has first term a1 and a common difference of d, then the sum of the first n terms is s sub n equals n over 2 times the quantity a1 plus a sub n. We could also replace a sub n algebraically and combine to get another form of the formula. S sub n equals n over 2 times the quantity 2 a sub 1 plus n minus 1 times d. Let's show how this formula is applied to a special problem. If a clock strikes the proper number of hours, each hour, on the hour, how many times will it chime in an entire month of 30 days? Let's see. The first hour, it chimes once. 12 hours later, it will chime 12 times. So in 12 hours, the 12th sum is 12 over 2, because we have 12 hours. That means we're looking at 12 terms. And a sub 1 is 1, and a sub n is 12. That will give us 6 times 13, which is 78. Now there are 78 chimes in 12 hours. That means that 78 chimes, it will do that 78 chimes twice each day, so that's 156 chimes per day. And if we assume that our month is 30 days, that'll be 156 times 30, which turns out to be 4,680 chimes per month. Now let's try one with summation notation. If we want to evaluate the sum of 2j plus 3 from j equals 1 up to 10, we have only to find the first and last terms. We can do that by substituting j equals 1. So our first term will be 2 times 1 plus 3 equals 2 plus 3 is 5. A sub n in our case is 10, and so we'll get 2 times 10 plus 3 is 20 plus 3 is 23. Now we'll apply our formula. S sub n equals n over 2 times the quantity a1 plus an. And substituting, we want the 10th sum, and we can do that by saying 10 over 2, a1 we found was 5, a10 we found was 23. 10 over 2 is 5, 5 plus 23 is 28, and 5 times 28 is our solution of 140. Now I'd like you to try one of these evaluate using the summation notation problems. Evaluate the sum from 1 to 12 of negative 5 minus 8i. Turn off the tape to do your work and back on when you're ready to see the solution. Let's see what the solution really is. We'll first calculate a1 to be negative 5 minus 8 times 1 is negative 5 minus 8 equals negative 13. We'll now calculate the last term, which is a sub 12, which is negative 5 minus 8 times 12, which is negative 5 minus 96, or negative 101. We'll now use the formula again, S sub n equals n over 2 times a1 plus an. We want the 12th sum, so we'll put a 12 there, and negative 13 is our a1, plus negative 101 is our a sub 12. That equals 6 times negative 13 and negative 101 is negative 114. And 6 times negative 114 is negative 684. I hope that's the solution you got to that problem. For our final problem, we'll look at how the graphing calculator can solve these problems as well. We're going to use the sequence feature of our graphing calculator to evaluate the sum of the first 10 terms of the arithmetic sequence if a sub n is 4.2n plus 9.73. Now this might not look exactly like the kinds of equations we've been dealing with so far, but what we've done here is just expand the expression and simplify it. Let's go to our graphing calculator now. In order to put in a sum of a sequence, we'll hit second function and list, and we'll go to first a math screen and see that our fifth choice is sum. Then we'll go to our second function list screen again, only this time we'll stop at operations, and we'll see that we want to choose 5 for sequence. We now should type in the equation that we're interested in using as a sequence. 4.2x plus 9.73. We put in a comma, and we have to state that our variable is x, put in a comma, state that our first term is going to be term 1, comma, and our last term is term 10, and end the parentheses for the sequence, end for the sum, and hit enter. Our solution is 328.3. Arithmetic sequences are formed by adding a constant from term to term. You should memorize the formulas associated with arithmetic series and sequences, practice by hand, and check your work with your calculator.